Something extraordinary is unfolding above our heads right now. As you watch this video, a traveler from another star system is silently crossing our solar system. And today, November 27, 2025, humanity begins its first truly global attempt to study such a visitor in real time. This is 3I Atlas, the third confirmed interstellar object ever detected, and for the next 2 months, the world's astronomers, coordinated under the United Nations Planetary-Defense framework, will launch the largest observation campaign ever organized for an object of this kind. What makes this moment historic is not only the object itself, but the fact that this campaign serves as a live rehearsal for how civilization might one day respond to a real cosmic threat. 3I Atlas was first detected on July 1, 2025, by the Atlas survey system in Chile, an automated telescope network designed to spot hazardous objects before they approach Earth. From the very beginning, astronomers noticed something extraordinary. Its orbit wasn't elliptical, like comets born inside our solar system. Instead, its eccentricity was measured at 6.139, far above the threshold of one that defines a hyperbolic orbit. This meant one thing: 3I Atlas is not bound to the Sun. It came from deep interstellar space. For comparison, the famous object Oumuamua had an eccentricity of 1.2, and comet 2I Borisov had 3.4. 3I Atlas surpasses them both, making it the most hyperbolic interstellar visitor ever observed. The comet reached its closest approach to the Sun, its perihelion, on October 29, 2025, at roughly 203 million kilometers, moving at an astonishing 68 kilometers per second relative to the Sun. Now, in late November, the comet is once again visible just before dawn, which is why the global observation campaign officially begins today. The International Asteroid Warning Network, IAWN, announced the operation on October 21st, and the effort will run until January 27, 2026. A narrow 2-month window in which astronomers can gather the most valuable data before 3I Atlas dims and vanishes into the darkness of interstellar space forever. Why invest so much effort into one object that poses no danger to Earth? The answer is simple. Comets are extremely difficult to track with precision, and precision is the foundation of planetary defense. Asteroids behave like clean points of light in a telescope, but comets do not. Their bright coma, glowing clouds of dust and gas, obscures the true position of the nucleus. Their tails distort measurements even more. As the Minor Planet Center explained, the bright features around a comet can pull measured positions away from the actual core. During an emergency, such errors could dramatically affect predictions of where an incoming object will strike. 3I Atlas is the perfect test subject because it travels fast, behaves unpredictably, and inspires immense public interest, all without posing any real threat. This is IAWN's 8th major global exercise since 2017, but the first using an interstellar object. Throughout the campaign, observatories around the world will practice pinpointing the nucleus within the bright coma, coordinating transit windows across multiple time zones, and submitting standardized astrometric measurements for analysis. Every observation strengthens the systems humanity would rely on if a genuine hazard were ever discovered. Multiple space agencies have already gathered early images. ESA's Mars Express and Trace Gas Orbiter photographed 3I Atlas from Mars orbit in October 2025, providing unique vantage points impossible from Earth. NASA's Hubble Space Telescope imaged the comet months earlier, revealing a teardrop-shaped dust cocoon and estimating the nucleus diameter somewhere between 440 meters and 5.6 kilometers. As 3I Atlas traveled through the inner solar system, it was also captured by Stereo, SOHO, Punch, and even the Perseverance rover on Mars. NASA's Lucy and Psyche spacecraft recorded their own distant observations in September. ESA's JUICE mission may add another perspective, though the data won't return to Earth until February 2026 due to deep space communication delays. Part of what makes 3I Atlas so scientifically valuable is its possible age. Some estimates place its formation between 7.6 and 14 billion years ago, potentially older than our solar system itself. For billions of years, this fragment has wandered through the galaxy, carrying with it the chemical memory of environments that existed long before Earth formed. By analyzing its composition and behavior, scientists can probe the building blocks of distant star systems. During this observation window, astronomers will concentrate heavily on astrometry, precise measurements of the comet's changing position relative to background stars. A workshop on November 10th trained participants on the specialized techniques needed to overcome the distortions caused by the coma and tail. The campaign officially launched on November 25th, and from now until late January, telescopes across the world will collect thousands of measurements as 3I Atlas moves through Virgo and Leo, gradually dimming to magnitude 12 before disappearing into the outer darkness. Although the comet poses no threat, the significance of this campaign is enormous. Planetary defense is not a national effort, it's a planetary one. The IAWN operates under the United Nations Committee on the Peaceful Uses of Outer Space, working alongside the Space Mission Planning Advisory Group to coordinate emergency responses should Earth ever face a genuine hazard. Training on a harmless interstellar visitor gives astronomers the freedom to test tools, communication chains, and techniques without the pressure of a countdown to impact. Every step of this campaign strengthens humanity's readiness. Continuous sky surveys like Atlas and others around the world serve as early warning systems. Rapid response observation networks refine orbits within hours of discovery. International coordination ensures that no single nation bears the burden alone. And exercises like the 3I Atlas campaign transform these systems from theory into practice. By January 2026, this comet will fade beyond the reach of Earth's telescopes and continue its journey through the Milky Way, destined never to return. But the knowledge gained, trajectory models, measurement techniques, compositional data, and improved coordination will remain. Each improvement becomes part of the global defense infrastructure that will one day protect Earth from a real threat. As telescopes around the world track this ancient traveler, remember this: every data point collected helps prepare humanity for the future. This is not just astronomy. This is planetary security. This is civilization learning to look outward together. If you want to follow the discoveries and understand the challenges of planetary defense, make sure to subscribe. The story of 3I Atlas is just one chapter in a much larger cosmic reality that affects us all.